Hello students, welcome back, and today I am going to tell you about the derivation of our third equation by graphical method. Now since we will be using this derivation of third equation with the help of the second equation. That's why I have not erased the derivation of the second equation, and for that same we have to take this velocity time graph, and along with that we have to take the help of this trapezium that we have got from this acceleration graph. Okay, now the trapezium, the area of the trapezium that we get is nothing but the distance covered by the body. And for that we use the parameters distance as s, initial velocity u, final velocity as v, acceleration as a, and time taken, I missed it out, time taken as t seconds. Okay, now the area of the trapezium s is equal to half into sum of the parallel side into, or it's a product of half into the sum of the parallel side and the height between the parallel side, or distance between the parallel side. So we write it as half into sum of parallel side. Now the sum of parallel side we can write it as QS plus OP, product of the height, that is the distance between the parallel side, that is OS. Now instead of QS we can write it as V, plus OP we can write it as U, and OS is nothing but T. Now remember, in the third equation of motion we do not have time as its factor. We do not take time as its factor. Now instead of time, what we take, we use the help of the first equation of motion. If you remember the first equation of motion, from here if we can derive the value of time, T is equal to change in the velocity by acceleration. Change in velocity by acceleration gives us the time. Now with this we can substitute this value of time here in this point. Okay, so here we get s is equal to half into v plus u, and instead of t we can write v minus u by a. Or we can also arrange it a bit, v plus u, v minus u. Now if you can recall, this one u plus v plus u and v minus u is a square minus b square, that is a plus b, a minus b, that is the algebraic equations we know. So we can write it in that way. So if we cross multiply we get 2as is equal to v square minus u square. Now what is that? We can again rearrange a bit. V square is equal to u square plus 2as. This is the third equation of motion, which uses initial velocity, final velocity, acceleration and distance traveled, but no time is used in this parameter. This is the third equation of motion. Clear? This is how we can derive the first, second and third equation of motion. Please follow my previous videos. There you can understand how we have used up all the graphical methods for deriving the first, second and third equation of motion. Stay tuned. Subscribe my video if you haven't yet, and join you with more of physics.